Okay, for part 2 of this video, for subtopic 1.3 forces in equilibrium, we are going to do two questions. Number 2 is a box of weight 50 Newton stationary on an inclined plane. So the question wants you to draw a free body diagram consisting weight, frictional force, and normal reaction. So let's draw on the diagram itself. So we have weight acting downward, normal reaction acting upward, must be 90 degrees to the plane, and we have frictional force acting against the motion of the box. Next, use triangle of forces method to determine magnitude of frictional force, Fr, and normal reaction. So to use triangle of forces method, we need to draw according to a suitable scale. So let's choose our scale. A suitable scale that can be used for this diagram is 1 centimeter to 10 Newton, which means that we have the weight component here, 50 Newton, can be drawn according to the scale, 5 centimeter. 5 centimeter, 50 Newton. Okay, next, second step is we can draw a rough drawing here, before we start drawing a scaled drawing. So your rough drawing of triangle of forces should look like something like this. Okay, something like this. Okay, so now the next step, draw a vertical line downward. So that should represent your weight. Okay, take 5 centimeter line of weight. So this one should be 5 centimeter to represent your weight. Next, draw a line which is 40 degree from horizontal. Okay, let's draw a horizontal line first. Okay, so let's say this is your horizontal line. Okay, draw a 40 degree. Okay, so make sure it is parallel. You see here, this is 40 degree. So draw a 40 degree line here, and that will represent your FR. Okay, you don't know the length of FR yet, just draw a straight line. Next, to draw the last line, which is R, one thing that you should know is the angle between W and the component perpendicular to the plane is also 40 degree. This is 40 degree, which is the same as the angle of the inclined plane. So take your protractor, tilt it to 40 degree. Okay, like that. And make a line connecting from W to FR. So this is your R, this is your FR. Use your ruler to measure, and you will get FR is approximately about 3.2 centimeter and R is about 3.8 centimeter. If you convert it to Newton, you will get 32 Newton and 38 Newton. So the second method to check the magnitude is to use resolution of forces method by calculation. So we are going to do that as well. So for that, we have to resolve weight into two components, which is Wy and Wx. So from here, Wy is actually equals to R since the object is in equilibrium, and Wx will be equal to frictional force. Okay, so this is your angle. Don't forget your angle, which is 40 degrees. You can form a triangle. So to find Wy, by now you should already know Wy is W cos 40. So substitute W, which given in the question is 50 cos 40, and you will get Wy 38.3 Newton. So Wy is actually same as R. So R must be 38.3 Newton as well. Next, find Wx. So Wx is W sin 40. So Wx is 50 sin 40, and you will get 32.14 Newton. So since Wx is in equilibrium with frictional force, then Fr is also 32.14 Newton. Okay, so now let's check with the answer that you got using scaled drawing. So R should be 38.3. So you got here 38 Newton, and Fr you got is 32.14. So here you got 32 Newton. So like I have explained before, using calculation will give you a more accurate value compared to the scaled drawing. Okay, the last question for this video. If you have a frame that is hung on a wall, and the weight of the frame is 12 Newton, draw free body diagram consisting weight and tension in the strings. So we know that tension acting in the string, you have two. You can draw roughly, your drawing should look like this. T connect with W acting downward, and second T. So that is your rough drawing. Calculate the value of T. Okay, so this time I want to use sine rule and cosine rule as an alternative method. Okay, so sine rule, let's recall sine rule. So sine rule is A over sine A equals to B over sin B equals to C over sin C. So in this diagram, you have to determine the angle first. Okay, so here is 70 degree, and here should be 55, and the other one is 55 as well. Okay, so you can put this triangle here and you will get something like this. Okay, so back to the sine rule. 12, so I'm going to use weight here as A, 12 Newton over sine 70 equals to T over sin 55. Okay, so from this equation, if you find T, use your calculator, you will get 10.46 Newton. Okay, the second method I want to use is cosine rule. So for cosine rule, c square equals to a square plus b square minus 2ab cos c. So substitute our values here. T square plus t square minus 2. T times t is t square cos c. So here cos 70. Okay. Plug in your value. 144. 2t square minus 2t square cos 70. Your t should be 144/2 minus 2 cos 70. So here I factorize t square and make it as a subject, and you will get t 10.46 Newton, which is the same answer if you use sine rule. There is another method, an alternative method if you do not want to use sine rule or cosine rule. So this is your original drawing, t. Okay, so what you can do here is you can split the diagram into two right angle triangle, and split the weight to 2 as well. So here half of the weight, the second triangle also bears half of the weight, tension acting on the string. Don't forget the angle, 50 degree, 55 degree, and 35 degree. So just use one of the triangle. So to find t, based on this triangle, you can use sin 35 equals to the opposite component, w/2, over hypotenuse, which is t. So sin 35 is 12/2, you got 6 over t. You use your calculator and you will get the same answer, which is 10.46 Newton. Okay, so that's all for subtopic 1.3, forces in equilibrium. Thank you.